are going to learn real numbers and their decimal expansions. Real numbers, already we have studied that. The collection of rational numbers and irrational numbers together called real numbers, and it is denoted by the capital letter R. Here we are going to study about their decimal expansions. How can we express it as a decimal number? That is real numbers. So real numbers, we know that rational numbers and irrational numbers, the collection of rational numbers and irrational numbers together called real numbers. So decimal expansion of these real numbers means it will come rational numbers and irrational numbers. So first let's see the rational numbers. Rational numbers. Let's see the decimal expansions of 10 by 3, 7 by 8 and 1 by 7. Let's see the decimal expansion of these three rational numbers. 10 by 3 is a rational number, 7 by 8 is a rational number, 1 by 7 is also a rational number. So first we will divide it, then only we will get the decimal expansion of these rational numbers. 10 by 3. 3 3s are 9, remainder 1, point, again digit is not there, so we have to put the point in the answer, point 0. 3 3s are 9, remainder 1, then again 0. 3 3s are 9, remainder 1, 0. 3 3s are 9, remainder 1, 0. It will go on. The division process will not end there. Its answer is 10 divided by 3. 10 divided by 3 is equal to, what we got the answer? 3.3333, etc. The division process is not going to end. It will continue here. That is 33333, etc. It will go on. Let's check next one. 7 divided by 8. 7 divided by 8. 7 divided by 8. It is not possible, so we will put 0. 0 into 8, 0. 8 zeros are 0. Now remainder 7. After getting the remainder, we can put the decimal point there and 0 here. 70 divided by 8. 8 8s are 64. Remainder 6. Then again we can put 0 here because already decimal point we put here, so we can put 0. 60. 8 7s are 56. Remainder 10 minus 6, 4, and again we can put 0 here. 8 5s are 40. 8 5s are 40. Remainder 0. So what is answer? 7 divided by 8 is equal to 0.875. Here the division finish here, and we got the remainder 0. Again remainder is not there. That division process finished. After the decimal point, finite number of digit only, that is 3 digit only there. That is division finish here. Then let's see next question. 1 by 7. 1 divided by 7. 1 divided by 7. 1 by 7 it is not possible. 0 into 7, 0. Remainder 1. Point you will put here and 0 here. 7 ones are 7. Remainder 3. Then 0. 7 fours are 28. Remainder 2. 0. 7 twos are 14. Remainder 6. 0. 7 eights are 56. Remainder 4. 0. 7 fives are 35. Remainder 5. 0. 7 sevens are 49. Remainder 1. Again 0. Remainder 1. You see, remainder 1. Then again it will repeat like this. If the remainder is 1, 0. 7 ones are 7 will come here. Again remainder 3 will come. 30. This same it is going to repeat. 0.142857, 142857, 142857, 142857, etc. It will repeat. So here 1 by 7 we can write. 1 divided by 7 is equal to 0.142857, 142857, 142857, etc. It will repeat. 142857 is repeating here. So now these decimal expansions you see, in the decimal expansion of 7 by 8, that division process it is finished here, division process is finished here, and we got the remainder 0. Then again digit is not there, it is not repeating. Division process end and remainder we got 0. So this type of decimal expansions are called terminating decimal expansions. Terminating means end. Ends. There is an end. Okay, that is the end of the division process. So such type of decimal expansions are called terminating decimal expansion. When we are dividing a rational number, if we are getting the remainder 0 means that division process end there, and again digit is not there, it is not repeating. So such type of numbers are called, or such type of decimal expansion is called terminating decimal expansion. Terminating decimal expansion. And now 10 by 3, it is repeating, that is 3.3333 etc. we got, that is repeating. And here also 0.4142857 it is repeating. So here it is not repeating, it is end of the division process, so it is called terminating. Here it is repeating, that is why it is called non-terminating. Non-terminating means division it is not finished, and some numbers are repeating there. Some numbers are repeating, that is why it is called recurring. It is called recurring decimal. That is non-terminating recurring decimals. Okay, non-terminating recurring decimals. It is here the division process end there, remainder we got 0, then that is why it is called terminating. Terminating means end there, that is terminating. Then here it is division process is not ending, that is why it is called non-terminating. Terminating, division end there, non-terminating, division is continuing or it is repeating, so it is called non-terminating. And some numbers are repeating here. Here 3 is repeating, here 142857 is repeating, 142857 is repeating, so it is called repeating. Okay, actually it is non-terminating repeating. Repeating means recurring, meaning it is repeating only. Recurring means it is repeating. Then now from here, that is only these cases when we are dividing a rational number, always we will get these two cases only. Either it will be terminating or it will be non-terminating recurring. So we can say that all the rational numbers, okay, rational numbers either will be terminating or non-terminating. Two cases only will get in case of a rational number. Either it will be terminating or non-terminating recurring. Either it will be terminating or non-terminating recurring decimals. Okay, terminating decimals or non-terminating recurring decimals. Then from here we can say about irrational numbers. Now we check only rational numbers. Then we are studying about real numbers. Okay, real numbers means both rational numbers and irrational numbers it will come. Both rational numbers and irrational numbers it will come. We checked only the decimal expansion of rational numbers. So decimal expansion of rational numbers it will come either terminating decimal, that means division process finish, remainder 0, that is such type of decimals are called terminating decimals. And other case it is it will not finish, it will not end, division process will not end, so it is called non-terminating, and some digits will be repeating, then that is called recurring. Then sometimes this non-terminating recurring decimal expansion we can denote it this way, that is 3.3333 etc. 3.333 etc. we can write it as 3.3 bar. 3 bar means 3 is repeating here. 3.3 bar means 3 is repeating. In this decimal expansion, it is a non-terminating recurring decimal, and non-terminating recurring decimals we used to write it as bar, that is which digit after the decimal point, which digit or block of digits it is repeating. Above that we will put a bar, then that bar means it is repeating, that number is repeating. Here how can we write that? We know that 0.142857 is repeating. So that we can write 0.142857 bar. 142857 bar means it is a non-terminating recurring decimal, and 142857 is repeating, means 142857, 142857, 142857, it is repeating. Now another way also it may come, that is 0.572, 72, etc. 72, etc. How can we write that one? 0.5 it is not repeating. See this one, 5 it is not repeating. 72, 72, 72, etc. it is repeating. So we can write 572 bar. 72 bar. That is 72 only it is repeating. 5 it is not repeating. After that 72, 72, 72, 72 it is repeating. So this type of numbers are called non-terminating recurring decimal expansion. Non-terminating recurring decimals. So remember, decimal expansion of rational numbers, two types are there. Either it will be terminating or it will be non-terminating recurring decimals. Okay, terminating decimals or non-terminating recurring decimals. Then from this we can say that about irrational numbers. That's opposite. Irrational numbers, the decimal expansion of irrational numbers will be non-terminating, non-recurring. Non-terminating, non-recurring. Non-terminating, non-recurring. Non-terminating, non-recurring decimals. Rational numbers will be either terminating or non-terminating recurring decimals. Irrational numbers will be, the decimal expansion of irrational numbers will be non-terminating, non-recurring decimals. Okay, now you see, I will show you an example. Suppose a decimal expansion 0.10, 100, 100, 1000, 1000, etc. It is a repeating. Division process, it is never end. So non-terminating. If the division process ends, then it is terminating. Division process is not ending, then it is non-terminating. Division process did not end. And the numbers, it is not repeating also. That is, here you see 3 is repeating, but here it is 142857 is repeating. That is, this block of digit it is repeating. Here 1 digit is repeating, here block of digit it is repeating, here 2 digit it is repeating. But here any number it is repeating or no, it is not repeating. 10 bar we cannot write, 100 bar we cannot write, 1000 bar we cannot write. So it is non-terminating, non-recurring. It is a division process, it did not end, and it is digits are not repeating after the decimal point. So it is called a non-terminating, non-recurring decimals. And these are the irrational numbers. Okay, that numbers are called irrational numbers. So we can say that irrational numbers are non-terminating, non-recurring decimals. Just opposite also we can say that if a decimal expansion is non-terminating and non-recurring, then it is an irrational number. So here also we can say the same way. Rational numbers are either terminating or non-terminating recurring decimals. If a decimal expansion is either terminating or non-terminating recurring decimal, then it is a rational number. Here irrational numbers are non-terminating, non-recurring. Just opposite we can say, if a decimal expansion is non-terminating, non-recurring, then it is an irrational number. So here non-terminating, non-recurring, division process did not finish, so it is called a non-terminating. Then digits are not repeating, bar we cannot write. This same way, bar we cannot write. So that is why it is called a non-recurring, not repeating. Digits are not repeating. So that is called non-terminating, non-recurring. Now some other examples I will give you. Root 2 is equal to 1.41, 32, 56, 78, etc. It will go on. It is a non-terminating. It is a division process. It will not finish. Non-terminating, and digits are not repeating. Okay, after the decimal point you see no digits are repeating, or the block of digits are not repeating. So root 2 is an irrational number. And lastly I told that pi is an irrational number. Pi value for the calculation we used to take 22 by 7 or 3.14, but it is not the exact value. Its exact value is 3.141 or 5926 7845 87, etc. Now you see, it is a non-terminating, division process not finished, and etc. it is there. Okay, that is why it is non-terminating. And after the decimal point, any digit is repeating. No, we cannot write this way. If 3 is repeating, then we can write 3 bar. If 142857 it is repeating, then we can write 142857 bar. And if 727272 it is repeating, then we can write 72 bar. But in this case, you see, any number bar we can write? No, we cannot write as a bar. So this type of numbers are called irrational numbers, and their decimal expansion is non-terminating and non-recurring decimal expansion. Okay, now let's see next exercise, that is exercise 1.3. Let's see the question, question number 1. Exercise 1.3, question number 1. Write the following in decimal form and say what kind of decimal expansion each has. Write the following in decimal form. First we have to make it as a decimal form, and we have to say what kind of decimal expansion each has, whether it is terminating or non-terminating recurring or non-terminating non-recurring. That we have to say. Non-terminating non-recurring it will not come, because these all the numbers are rational numbers only. Non-terminating non-recurring it is an irrational number. So here all it is rational numbers only. So either it will come terminating or non-terminating recurring it will come. So let's see first question. 36 divided by 100. 36 divided by 100. No need of dividing this one. 36 divided by 100, denominator 2 zeros are there. So write the same number and put 2 decimal points. In the answer, 2 decimal places it will come. That is the answer, 0.36. 0.36 is the answer. Even if you are dividing this one also, it will come 0.36. If you want to do, you can do it. Then 0.36. Division process will finish and you will get the remainder 0. So it is a terminating decimal. So here we have to write it is a terminating decimal. It is a terminating decimal. And now second question, 1 by 11. Question number 1. Number 2, 1 divided by 11. Divide it and see. 1 divided by 11. 1 divided by 11. 1 divided by 11 is not possible. 0 we have to put. 0 into 11, 0. 1 minus 0, 1. We got the remainder. So now we can put the decimal point here. Then we can put 0 here. Again, 10 divided by 11, it is not possible. So again we have to put 0. 0 into 11, 0. Remainder 10. Again we can put 0 here. So what will come answer? 11 into 9, 99. Remainder 1. Remainder 1 again it came. Remainder 1, 0. 1 0 only we can put here. Then 0 into 11, 0. Then remainder 0. Now here we can put 1 0. 100 divided by 11, 9. 9 into 11, 99. Now you see this one. 09 is repeating. It is going to repeat 09. Again you see here remainder it will come 1. 09 it is repeating. So here the answer is 0.09, 09, etc. That we can write as 0.09 bar. 0.09 bar. Therefore, if bar is there, then it is a, which type of decimal expansion is that? It is non-terminating recurring. Non-terminating recurring decimal. Non-terminating recurring decimal. So this way you can find out remaining questions also. Just divide it, that two numbers, divide it, and what you are getting the decimal expansion, according to that you have to write whether it is a terminating decimal or a non-terminating recurring decimal. That you have to write, that much only there. So remaining questions you do it by yourself. And question number 2 also, you try it by yourself. Now let's see question number 3. Okay, now see the question. Question number 3, express the following in the form P divided by Q, where P and Q are integers and Q not equal to 0. Express the following in the form of P divided by Q. We have to express these numbers in the form of P divided by Q, where P and Q are integers and Q not equal to 0. Where P and Q are integers and Q not equal to 0. First question, 0.6 bar. Second one, 0.47 bar. 7 only bar. Okay. 4 it is not repeating, 7 only repeating. Third question, 0.001 bar. 0.001 bar. We have to express it in the form of P divided by Q. We know that these are non-terminating recurring decimals. Non-terminating recurring decimals are rational numbers. So we can make it in the form of P divided by Q. Okay, let's see how can we make it in the form of P divided by Q. So first we will do the first question. 0.6 bar. Question number 1. 0.6 bar. First we will take, let x is equal to 0.66666 etc. Equation 1. That is 0.6 bar means 6 is repeating. After the decimal point 6 is repeating. That is why I wrote here 0.6666 etc. That we will take equation 1. After that we will write multiplying both sides by 10, we get, what is that? If we are multiplying both sides by 10, and now I will tell you why I have multiplying by 10. Because here after the decimal point one digit is repeating, so that is why I am going to multiply both sides by 10. If two digits are repeating, then you have to multiply 100. After the decimal point, if three digits are repeating, just like this, here three digits are repeating, so you have to multiply by 1000. So that is the rule. Here only one digit is repeating, that is why 10. Both sides we have to multiply. So 10 into x is equal to, what is answer? 10x is equal to 10 into 0.6666 etc. If you are multiplying 10 into a decimal point, its decimal number, then its decimal point will go one place right side, it will become 6.6666 etc. That we will write equation 2. Now subtracting equation 1 from equation 2, we get, what will we get? Subtracting equation 1 from equation 2. Equation 1 we have to subtract from equation 2. That means it will come 10x minus x. 10x minus x is equal to, what is answer? 9x is equal to 6.6666 etc. minus 0.6666 etc. Subtract it here. 6.6666 etc. minus 0.6666 etc. Then right hand side all it is 6. 6 minus 6 0. 6 minus 6 0. 6 minus 6 0. 6 minus 6 0. 0 0 0 only you will get here. 6 minus 0 6. 6.0000 means what is answer? That is 6 ohm. Therefore x is equal to, what is answer? 9 transposing to right side, it will become divided by 9 because it is into 9. Now we can cancel it. 3 2s are 6, 3 3s are 9. So x is equal to, what is answer? 2 divided by 3. Therefore x means we have taken 0.666 etc. That is 0.6 bar. So therefore 0.6 bar is equal to, what is the P by Q form? 2 divided by 3. 2 divided by 3. That is the answer. Now we have expressed the 0.6 bar in the form of P divided by Q. Then now let's see second question, 0.47 bar. Okay, see this question. Question number 2, 0.47 bar. So here also same way, let x is equal to, we will take 0.47 bar. That means 47777 etc. That we will take equation 1. Now multiplying both sides by 10. Here also I am multiplying both sides by 10. Why? Because after the decimal point one digit is not repeating, that is why we have to multiply it by 10. Then 10 into x, it will come 10x is equal to 10 into 0.4777 etc. This decimal point will go one place right side, it will become 4.7777 etc. That we will write equation 2. Now after the decimal point one digit is repeating, so again we have to multiply both sides by 10. Multiplying both sides by 10. Multiplying both sides by 10, we get, what will get answer? Here in this second equation, 10 into 10x, that is 100x is equal to, again 10 into 4.777 etc. What will get answer? This decimal point will go one more place right side. That will become 47.7777 etc. That we will write equation 3. Now in this question we are going to subtract equation 2 from equation 3. Subtracting equation 2 from equation 3. So here we have to write subtracting equation 2 from equation 3, we get, what will get answer? 100x minus 10x, 100 minus 10, that is 90x is equal to 47.777 etc. minus 4.777 etc. It will come like this. 47.77777 etc. minus 4.7777 etc. Subtract it. 7 minus 7 0, 7 minus 7 0, 7 minus 7 0. Then 7 minus 4, that is equal to 3, 43.0000 etc. That is 43. Therefore, x is equal to what is answer? 43 divided by 90. 90 transposing to right side divided by 90. X we have taken this one 0.4777 etc. That is 0.47 bar. Therefore, we can write, therefore 0.47 bar is equal to what is answer? 43 divided by 90. That is the answer. Okay, now let's see question number 3. 0.001 bar. Question number 3. 0.001 bar. First we will take, let x is equal to 0.001 001 001 001 etc. Equation 1. Multiplying both sides by which number we will multiply here? 1000. We get, why we are multiplying it by 1000? Because 3 digits are repeating. After the decimal point, 3 digits are repeating. That is why we are multiplying it by 1000. So 1000 into x is equal to, what is the answer? 1000 x is equal to 0.001 001 001 etc. into 1000. This decimal point will go 1, 2, 3 place right side. It will become 1.001 001 001 001 etc. That is equation 2. Now subtract these two equations. That is subtracting equation 1 from equation 2, we get, what will get as 1000x minus 1x. 1000 minus 1, that is 999x is equal to 1.0001001 001 etc. 1.001 001 etc. minus 0.001 001 etc. is equal to, what will get answer? 1 minus 1 0 0 minus 0 0 0 minus 0 0, all it will come 0 only. After the decimal point, all it will come 0. 1 minus 0, it is 1. 1.000 etc. means it is 1 only. Then x is equal to 999, transposing to right side, we will get answer 1 divided by 999. Therefore, x is equal to, what was the question? 0.001 bar is equal to, what we got answer? 1 divided by 999. That is the P by Q form of 0.001. Okay, dear children, write down it in your notebook. The remaining questions we will do in the next video. Thank you so much.